Have you ever really stopped to wonder what's going on inside the quote-unquote mind of a self-driving car? I mean, it's not just about cameras and sensors. It's really about learning to make these split-second decisions in a world that is just full of surprises. Today, we're going to dive deep into how a car actually learns to think, using this incredibly powerful technique called deep reinforcement learning.
So, how does a self-driving car even begin to see and act? Well, it all follows this basic pipeline you see here. First up, it has to sense the world with its eyes and ears. You know, cameras, LiDAR, radar, the whole suite. Then it has to perceive what it's seeing. Is that a person or a lamppost? Am I in the right lane? After it builds this digital representation of the world around it, it gets to the hardest part, planning and deciding what to do next. And only after all that does it finally take control of the wheel, the gas, and the brakes.
And this really nails the core of the problem. You see, thanks to all the big advances in deep learning, that seeing part, we've gotten really, really good at it. But the deciding part, that's the real frontier. It's not just one choice. It's this constant stream of decisions where every single move you make, like just tapping the brakes, completely changes the situation for your very next move.
So that's the big question, isn't it? How on earth do you teach a machine to handle the completely unexpected? A car suddenly swerving, a pedestrian stepping out from behind a bus. You just can't program a rule for every single possible thing that could happen. It's impossible. You need a totally different approach. You need the machine to learn from experience, just like we do.
So, if you can't write a rule for every surprise, you have to let the machine learn from them. And that brings us to our first huge concept, reinforcement learning. At its heart, it's really just a framework for learning by doing, through simple trial and error. Kind of like how you or I would learn a new skill.
This quote from the research really sums it all up perfectly. An autonomous agent, that's our car's AI, learns to get better by interacting with its environment. Now, to really get what that means, let's break down the three key pieces of that puzzle: the agent, the environment, and how it actually learns.
First up, you have the agent. This is the brain of the whole operation, right? The AI that's making all the calls. You can think of it as our student driver.
Now, the agent doesn't exist in a vacuum. It's inside an environment. And for our car, that's literally everything outside of its own digital mind. The physical road, the other drivers who might be unpredictable, the weather, the rules of traffic. It's messy, and it's always changing. So, how does our little agent know if it's doing a good job? That's where the reward comes in. Seriously, just think of it like a score in a video game. A nice, smooth, safe lane change, you get positive points. Getting way too close to another car or, causing a crash, that's a huge negative penalty. And the agent's one and only goal is to rack up the highest score it possibly can over its entire trip.
And this all comes together in what we call the reinforcement learning loop. It's super simple, but powerful. The agent observes the state of the world, it takes an action, it gets a reward or a penalty for that action, and then, this is the key, it uses that feedback to learn an updated strategy for the next time it's in a similar spot. And this loop just runs over and over, millions, even billions of times.
Now, this whole process creates a really interesting dilemma for the AI. It's this constant balancing act. On the one hand, it needs to exploit what it already knows works, stick to the safe moves that it knows will get it a good score. But on the other hand, it has to explore. It has to try new, maybe even kind of weird maneuvers to see if it can discover an even better, more efficient way of driving. If you lean too far one way, it just gets stuck in a rut. Too far the other, and it's just driving randomly, never really mastering anything.
Okay, so learning from rewards can mean a couple of different things. Let's take a quick peek inside the AI's brain at two of the main strategies it can use.
So there are two main ways the AI can think about this. A value-based approach is kind of like a chess grandmaster, always thinking several moves ahead. It tries to calculate the future value or the score of every possible move it could make right now. In contrast, a policy-based approach is way more intuitive. It doesn't really calculate scores, it just learns a direct link from a situation to an action. A policy. Think of it like muscle memory. When you see a red light, you just hit the brake. You don't calculate the long-term value of braking. And as you can probably guess, the most advanced systems out there are finding really clever ways to combine both of these strategies.
All right, so that's the theory. But how does all this translate from a cool concept into actual code that's driving a car on the street? Let's take a look at how RL is being used in the real world.
And I want to be clear, this is not just some niche theoretical idea. The field is absolutely exploding. I mean, just look at these charts from the research. On the left, you've got the number of publications on deep reinforcement learning in general, and you see that crazy hockey stick curve starting right around 2016. Now look at the chart on the right, which is specifically for autonomous driving. It's the exact same pattern. This shows you just how central this technique has become to the entire industry, and it's all happening really, really fast.
So what researchers are doing is using different flavors of reinforcement learning to tackle very specific driving challenges, almost treating each one like a mini-game the AI has to beat. For something pretty straightforward like staying in your lane, they might use a method called DQN. But for a much more complex task like merging onto a busy highway, which requires remembering what happened a few seconds ago, they might use something more advanced, like an LSTM. The point is, they're creating these specialized brains to solve each of these really tricky driving puzzles one by one.
But you can't just let a brand new AI learn by trial and error on a real street. Come on. That would be incredibly slow, wildly expensive, and of course, extremely dangerous. The only way you can possibly run through billions of these learning cycles is inside of high-fidelity simulators.
But simulators aren't perfect, and that brings us to the major roadblocks that are still standing in the way of full autonomy.
You see, inside a simulator, the world is often perfect. It's a clean, predictable grid. The laws of physics are perfectly known. The other cars behave according to a set of rules, and the sensor data is crystal clear. It really is an ideal training ground.
The real world, though, the real world is none of those things. It is messy. It's totally unpredictable. The data from a camera can get washed out by sun glare or blurred by rain. And human drivers do things that just defy all logic. This disconnect between the clean simulator and the messy real world is a huge, huge problem.
And this sim-to-real problem is actually one of 4 major hurdles the entire field is working on right now. First, there's bridging that reality gap we just talked about. Second is sample inefficiency. Right now, these AIs need billions of miles of practice, way more than a human. How can we make them learn faster? Third is the exploration problem. How do you let the car experiment on real roads without ever causing even a fender bender? And finally, the biggest challenge of all, the safety guarantee. How do we prove beyond any doubt that this AI is truly safe?
So what we're seeing is this powerful, incredibly adaptable way for cars to learn from experience, getting just a little bit better with every single simulated mile. But as this technology moves from the simulator to our actual streets, the technical challenges start to give way to a much more human question. A question of trust. The ultimate question isn't just whether a car can learn, but when will we decide that its experience is finally enough to earn our own?